Yalimadat, everybody. My name is National Verjee Babul. I'm a member of the National ITREB. Welcome to our first webinar for Horizons Conference webinar series. I just want to thank the entire Horizons Conference webinar team. Their names are listed there. So I want to start with a speech that was made by His Highness the Aga Khan in Ottawa, Canada on December 6, 2008. And this was the inspiration for the series. What he said was, and the more we discover, the more we know, the more we penetrate just below the surface of our normal lives, the more our imagination staggers. Just think, for example, what might lie below the surfaces of celestial bodies all across the far-flung reaches of our universe. What we feel, even as we learn, is an ever-renewed sense of wonder, indeed a powerful sense of awe and of divine inspiration. This was the inspiration for the Horizons Conference webinar series. We will bring to you scholars and other experts to share their knowledge and expertise to inspire the Jamat. This is a collaborative project between the National ITREB and the National Education Board. We have an absolutely fabulous lineup of speakers. And our first speaker, if we can go to the next slide. Our first speaker is Dr. Firoz Verjee. Firoz completed his doctoral studies in systems engineering at George Washington University and specializes in natural hazard risk and emergency management. He was responsible for initiating the AKDN's Greenhouse Gas Emission Management Program in 2016-2017, while he was head of operational research for the Aga Khan Agency for Habitat in Geneva. I've had a sneak peek at some of his slides, and you are in for an amazing treat. He has the most amazing presentation. So Firoz, please take over from here.
Thank you so much, Naz, and thank you to the National Council of Canada for inviting me to give this webinar. Yalimadad to all the participants who are able to join this presentation about Antarctica. Before I get started, I wanted to convey my thoughts to all those who have been impacted by the ongoing pandemic, whether that's professional or personal. It's kind of encouraging to note that Antarctica is actually the only one of the 7 continents that has no reported cases of coronavirus. And during the presentation today, I think you'll discover why that's the case. But overall, we've been inundated with the news coverage, and I think hopefully you'll find the images and the discussion today a bit of a break from what you've been consuming intensively for the last month or so. And I hope you find some levity and some relief from the presentation today, maybe some inspiration as well. In terms of an outline for today's presentation, we'll stay on the previous slide, please. In terms of the outline, we'll start off with a brainstorming exercise and try and get you to start thinking about Antarctica, what it means to you, what kind of impressions you have about Antarctica from the different sources of information you've had in the past, whether they're movies or science lessons or documentaries. We'll then spend quite a bit of time, actually, before we jump into the photos, talking about the geography of Antarctica, the paleo history of Antarctica, and some core facts that I think may jog some memories, but also may be quite new for a lot of us who studied science many years ago, and Antarctic science is not something which was that well known many years ago. So we'll spend a little bit of time getting some bearings about what it means to talk about Antarctica. We'll then start to ease into our expedition and talk about the subantarctic environment and contrast that with the Antarctic Peninsula using some of the photos from my recent expedition. And then we'll conclude with a discussion about how Antarctica is governed today and what are some of the issues related to climate change that are obviously prescient and very much in the news on a regular basis that will then give us, I think, a lot of opportunity to discuss as a group these issues. So we'll conclude with a Q&A and a discussion. This is a webinar, so I'm really happy if there's a level of interaction and if there are other specialists online who would like to jump in and contribute. The other thing that I'll mention before we move on is that the technology we're using today may or may not allow you to see my images in full resolution. So if you're having trouble today really appreciating the imagery on the device you're using, send some feedback and we will respond with a link to the full resolution album, which is online, and you'll be able to look at that at your leisure after today's session. All right. All right, next slide, please. Okay, let's do a bit of a brainstorming. I'd love to know kind of what comes to mind to those online when we use the term Antarctica. What are some of the key words that come to mind when you think of Antarctica? And you can respond in the chat if you have access to that. What are you thinking of with that word? What impressions do you have from movies like Happy Feet or March of the Penguins? What impressions do you have about Antarctica that may have been inspired from recent news coverage about climate change? All right, there's some shooting bullets here, moderator, so I'll just ask you to hit the series that are on the left side of the screen now. So some of the words that you might have thought about now in this brainstorming are words like barren, empty. You might associate Antarctica with the words cold or freezing or icy. White seems to be a pretty synonymous color with the word Antarctica. Remote, disconnected, inhospitable, forbidding. Keep going, please. Yeah, untouched, pristine. You may also think of Antarctica as a very, very flat and low-lying and just vast plain. You may think of it as inert and very static and motionless. And certainly you may think of it as just a continent full of all these penguins that are marching around doing comical, funny things. Well, I think after today's presentation, I'd like you to move perhaps towards a more nuanced impression. While none of those things are totally wrong or right, I think that the images that we share today will introduce you to a richness and a diversity of geography, of ecology. The notion that while it is an extremely cold place, it is warming. And there are trends of warming that are very apparent to even a short-term visitor like myself. That while white is still the dominant color, there are some beautiful greens and browns and blues and grays that we discovered that we were not expecting that far south. And while it is certainly the most remote place in the world, it is increasingly accessible. And there are lots and lots of impacts that obviously that accessibility involves. It is very much a forbidding, inhospitable, almost a fortress when you approach it from most sides, but it is also very fragile, and it can actually be very easily impacted. And in fact, it has had a lot of engagement with humanity around its periphery and at certain spots in its interior for more than a century. So, and while those changes are currently being managed very carefully, inevitably it is changing. The other thing that I think a lot of people find surprising about Antarctica is that it is not just a flat, barren landscape like we would associate, with example, with the Arctic ice sheet. It is in Antarctica a very mountainous and high plain. In fact, it's the highest continent in the world. And I think, as I've mentioned, it is changing. It is dynamic, and it's a really, really interesting place to go and study because it's constantly changing. Okay, let's go to the next slide. Well, I mean, this is typically the perception we have of the continent geographically, right? So if you look at the image on the left, you would be looking at a two-dimensional map that is far more representative and quite frankly more fair to how Antarctica appears, and that's called a polar orthographic projection. But if you look at the image on the right, the map on the right, that's often how we look at the world. And that Mercator projection tends to favor the inhabited continents, and to some extent is really unfair to the appearance of Antarctica. So as we move away from the equator, further north and further south, there is a massive exaggeration of landmass. And the actual landmass, for example, of Greenland is certainly not bigger than Africa. But in the projection on the right, it does appear that way. Take a look at Antarctica on the bottom of that left side, or of that right side image. It's vastly exaggerated when in fact it looks a lot more, when you look flat on, like the image on the left. So that leads to the question, how large is Antarctica in reality? Next slide. Well, here's an overlay of Antarctica with the United States, the continental United States. So you can see that in comparison, Antarctica is about 14,200,000 square miles. So it's actually quite a bit larger than the United States. In fact, it's about the size of the USA and Mexico combined. And it's the 5th largest continent. It's nearly twice the size of Australia. So it is a huge landmass. If it was a country, it would actually replace Canada as the 2nd largest nation in area. So Russia would still remain in number 1 position, but Antarctica would replace Canada as the 2nd largest country if it was a country. Antarctica is the highest, driest, coldest, windiest, and brightest of the 7 continents. In most areas, it is at least 1 to 3 miles thick in ice coverage, about 2 kilometers average ice thickness throughout the continent. And that ice is accumulated over millions of years through snowfall over antiquity. Presently, the Antarctic ice sheet contains about 90%, 90, of the fresh water on Earth. So if it were to completely melt, and nobody's predicting that in the short term, but if it was to completely melt, it would raise sea levels by about 70 meters, 70. So it does have the vast bulk of freshwater content in the world in frozen format. So let's think about how this incredible continent has formed over time. Next slide, please. Now, I do apologize. Maybe these are somewhat scientific and intimidating looking slides. We'll start looking at some photos really soon, I promise you. But I think this is fascinating. And I think this is really important for even those of us that barely remember plate tectonics and things like that from school to just remind ourselves of. The images on the left show that Pangaea, which was the supercontinent that led to the creation of the current continents, started to break up about 200 million years ago. And the supercontinent then broke into 2 supercontinents. North America, Europe, and most of Asia were originally part of Laurasia. And the rest of the world was part of something called Gondwana land. And you can look at those in the upper right side of the left image. Over time, they separated, and Gondwana land shifted south, and then also started to break apart. And as a southerly supercontinent, Gondwana land was much warmer than it is today. So Antarctica did not have an ice sheet on it. It was full of life. Dinosaurs roamed its lands, and in fact, during the Jurassic period, much of Gondwana land was covered by lush rainforests. You know, about 180 million years ago, Africa and South America started to break apart, and then that process continued. They started to shift south, and then finally, about 45 million years ago, Australia and Antarctica finally started to split apart. And at that point, Antarctica started to freeze over. The Earth's climate started to cool. Australia drifted slightly northwards, and it continues to drift northwards at a rate of about 3 centimeters per year. And we're left now with Antarctica at the southern pole as a very, very cold environment. But its history is not always a cold polar environment. It actually was very much a subtropical environment. And you'll see that in the fossils that you discover in Antarctica. On the right side, there are a couple of images there. And I think the point that I was trying to make with those slides is that Eastern Antarctica is geologically really different from Western Antarctica. Eastern Antarctica, believe it or not, is hundreds of millions of years old in terms of its geology, and it actually was formed through processes which started to occur on the planet 3 billion years ago. As you move to the western part of Antarctica, that peninsula that's in green, you're looking at a rock and geology that was formed through volcanic and metamorphic processes just in the last 60 million years. So it's relatively young. And even as a short-term visitor, you can observe pretty significant differences in the terrain, in the geology, in the landscape, and the age of those rocks. Finally, the image on the right just tries to make the point that these continents are still on the move. Those blue lines are vectors, and the length of the lines indicate how fast the continents are moving and in what direction they're moving. And you can see that that Australia is shifting northwards at about 3 centimeters per year, 4 centimeters per year in some spots. Antarctica is actually shifting towards the western hemisphere at a certain speed as well. So these continents are still moving around on the surface of the planet. All right, let's go to the next slide. I want to make sure that everyone feels comfortable with some of these terms that we'll be using today. And so I've got a few definitions there with arrows pointing to them. So when we refer to the sub-Antarctic region, we are politically referring to the area north of the Antarctic Circle. But scientifically, we're actually referring to the area north of where the warmer waters of the subtropical seas meet the really cold waters of the Antarctic Ocean. And that mixing of water, cold northern flowing water with warm southern moving water, results in a very, very high level of mixing and dynamics and upwelling that creates a very, very rich environment for bioproductivity, and marine productivity is very rich there. You've got a lot of Antarctic krill, which is basically a key part of the food chain. And that little squiggly blue line around Antarctica that's illustrated there is essentially about 30 to 50 kilometers wide. And that Antarctic convergence zone really separates the subantarctic from the Antarctic environment. The Antarctic region is contained within that blue line, and it really is a natural boundary between these areas. The Antarctic Treaty area, and we'll be talking about the Antarctic Treaty towards the end of today's presentation, is basically the region defined 60 degrees south latitude. And it's an area that is a legal definition that basically says this is the area that we're going to collectively manage as an international group of members to this treaty, and that's the definition there. So it's purely a legal boundary. And in black, you'll see Antarctica is really the continent itself. So we'll switch between Antarctic region, for example, and Antarctica. Those are the distinctions between those terms. Also take a look at the place names before we go to the next slide, and you'll see that there are names like Dronning Maudlang, Grahamland, Palmerland, Queen Elizabeth Land, Victoria Land, George V Land, Queen Mary Land. What you'll notice there is a pattern that most of the geographical names are rooted in imperial conquest. The glorification of monarchs and their families were often used to justify land claims by the early explorers of the region. So Antarctic place names were first given by really brave explorers, starting with Captain James Cook in the 1790s, and then intensively over the 19th and the 20th centuries, explorers from all around the world who made it that far would immediately christen geographical features with the names of their monarchs or their leaders as part of the effort to lay claim to Antarctica as sovereign territory. Another strategy that was used and has continued to be used since then are the establishment of research stations on Antarctica and on the surrounding lands. And actively researching Antarctica has historically been seen as a strategic benefit for the countries that were going to, in the future, be able to defend claims to sovereignty in Antarctica. Next slide. This map, I hope it's visible for folks on a smaller screen, but this map aims to show the number of countries and the location of research that is currently underway in Antarctica, or at least as of 2006. You'll see the flags of many nations. Many of these are pioneering nations in Antarctic exploration. Some of them are newer and latecomers, but they're all indications of the fact that people have investments in research and science. They are all members of the Antarctic Treaty in order to be there. And the attempt is often to be able to collect information, collect science, and visibly show that there's an active engagement with that part of the world. As of October 2006, there are about 42 countries that were operating either summer or year-round research stations on the continent. And at their peak, all of the stations basically involve a population of 4,000 inhabitants in Antarctica during the summer, which drops down to less than 1,000 during the winter, which is our summer. So the population is less than 5,000 at the busiest times of the year in a huge continent. And in fact, some of those are very temporary camps that are moving around. I mentioned that coronavirus has not been confirmed in Antarctica, and there are no reported cases. You can see why. There are very few people that live there. There are no permanent inhabitants. There are no indigenous populations, of course. And anyone who gets to go to a station, and even tourists who have the opportunity to go and do some exploration in Antarctica, must undergo health assessments. So in order to protect the ecology, but also to protect those in a confined environment of a research station, there is very little chance to actually get infected there. So it's the ultimate place to quarantine during a pandemic. It's a very safe place. All right, we'll go to the next slide. And we're nearly at the photos, so thank you for bearing with me. I did want to sort of present a little bit more information here. This is something as Canadians we can be very proud of. This is a collection of images that was used to develop an elevation model, the first such elevation model of Antarctica. It was done about 23 years ago, and it reveals that the elevation of the continent is quite high. You can see the Vinson Peak, or the Vinson Massif in Western Antarctica. That's almost 5,000 meters high. And you can also see how Eastern Antarctica is generally a very high plateau. And even the South Pole is very, very high in terms of elevation. And it's just the perimeter of Antarctica that is low-lying. You know, I first became really curious about Antarctica in the mid-1990s because I was actually involved in the RADARSAT mission. And when I was with the RADARSAT mission, it detected a huge portion of an ice shelf that broke off from the mainland. I'll just ask you to advance to the next slide. I think it's just loading. There we are. So you can see that the Larson Ice Shelf, actually part of that shelf broke off in the 1990s, and it was followed by a number of other major international news stories about pieces of ice the size of Belgium and Manhattan drifting off and breaking away from the mainland. And that raised a lot of concern about what was happening with climate change and potentially sea level rise. This image shows the movement of Antarctic glaciers. So you can see that the legend shows a velocity model, and the red areas are areas which are moving, in some cases, hundreds of meters, even thousands of meters per year. The fastest moving glacier is actually often referred to as the Doomsday Glacier, and that's the Thwaites Glacier on the left side of the screen. That was in the news earlier this year. You may have heard the news that Thwaites had actually started to move very fast. It's the second fastest moving glacier in the world. The fastest one is actually in Greenland. But you can see the Ross Ice Shelf, the Rhone Ice Shelf. They are moving on the order of 1 to 2 kilometers per year on average. Sometimes they go above 2 kilometers. And even in Eastern Antarctica, which is generally thought of as less dynamic than Western, there along the perimeter are a number of shelves, a number of glacier streams that are moving at significant velocity. So I hope this dispels sometimes the impression people have that the ice is just static and not changing. This is a continent on the move on the most part, and over time you can see how significant the shifting of ice, the breaking of ice shelves is. And the consequence, obviously, is when ice shelves break, they no longer hold back the glaciers that are otherwise being held back and prevented from melting into the sea. They serve almost like a dam or a cork along these valleys. And when the ice shelves break from the mainland, they actually enable the glaciers that they're holding behind to flow more freely and to melt more freely. So these are very significant events for us in climate change. Let's go to the next slide. I wanted to just quickly show why that elevation is the way it is. If you were to remove the ice cap off the top of Antarctica, you would reveal a very low-lying continent, and in fact, much of it would be below the waterline, as shown there. There are a number of lakes and rivers, and historically that you would discover, and you know, a large amount of fossils and remnants of its subtropical history. But that ice cap, that really, really thick ice cap, gives it its elevation, it gives it its appearance, and it gives it its morphology. So it is really quite a different continent without that significant volume of ice that it has. Okay, let's go to the next slide. Let's look at some pictures. I think that was enough of a science lesson. I think that we'll be able to enjoy some of these images from this recent cruise. Now, we did not go to all of Antarctica. We actually just had a taste of the most commonly visited part of Antarctica, which is the Antarctic Peninsula. Most expeditions would leave the southern tip of South America. There's a port called Ushuaia in Argentina. And ours happened to move east to the sub-Antarctic islands of South Georgia, and then moved their way across to the Scotia Sea, across to Elephant Island, and then a few spots on Antarctica. And we'll look at some of those images now. Next slide. The first leg of the expedition was to really move across South Georgia. So you would sail out through Ushuaia towards Africa, east, and you'd pass by the Falkland Islands. I think you may need to hit the button one more time. It's about a 1,134 nautical mile journey, a 2,100 nautical mile journey to South Georgia. Before we go to the next slide, just observe the bathymetry, the seafloor at this part of the South Atlantic Ocean, and connect it with Antarctica. You can see that, in fact, they are part of the same geological relationship, South America and the Antarctic Peninsula. And the perimeter that they form is called the Scotia Plate. And you can see where the Antarctic Plate and the Scotia Plate meet on the right hand or the eastern side of the Sandwich Plate. Okay, next slide. As we left the port and as we sailed out through the Strait of Magellan. Many of you may have heard of legendary tales about the Strait of Magellan. It's considered one of the most important natural passages between the Atlantic and the Pacific Oceans. It has been traversed by explorers and others throughout history, and it's named after a Portuguese explorer, Ferdinand Magellan, who in fact named the Strait of All Saints, Estrecho de Todos los Santos. His benefactor was a Spanish king, Charles V, and he financed Magellan's explorations, and in his honor for being the first explorer to circumnavigate the globe, he changed the name to the Strait of Magellan in the early 1500s. So this is an image just as we're starting to leave the mainland and move through the Strait of Magellan. Next slide. Along the way, you see wonderful seabirds and sea life, and the legendary albatross is something that we were really, really fortunate to see lots of. This is a black-browed albatross. It's typically a medium-sized albatross of about 2 or 2.5 meters in wingspan, huge birds. And it can have a natural lifespan of over 70 years. Now, until 2013, this was classified as an endangered species. And there had been a 67% decline in the population over the last 60 or 70 years, largely because of fishing and bycatch. But we did see quite a few, and it's no longer endangered. It's now considered to be of lesser concern these days. Next slide. Another very, very exciting bird to see is predatory bird. It's a predatory seabird of the southern oceans called the northern giant petrel. And its largest colony is, in fact, South Georgia, where we're heading right now. The northern giant petrel feeds mainly on dead penguins and seals called carrion, as well as fish, krill, squids. It'll follow fishing boats and cruise ships, and it'll pick off any discarded waste from those ships. And it's relatively aggressive. It'll kill other seabirds, like penguins or any sick or injured chicks or anything like that. And it'll even go after the albatross. So it is quite an aggressive bird, very, very graceful and significant bird, though. Next slide. As we arrived in South Georgia, and remember this is a sub-Antarctic environment, we touched on a number of ports and towns and bays. Grytviken was our first stop, and it's a historic town if you want to look it up. It was the largest whaling station historically. A lot of the whalers used to drag or pull their catch here, where they were stripped for their blubber and for their baleen. It is still a British protectorate. It's a British overseas territory, and the British are very actively involved in the management of this island. It no longer has any permanent residents, and it's really popular for those that are interested in Antarctic history, because the legendary polar explorers Ernest Shackleton and Frank Wild are actually buried in this area. Commercial sealing was also a very, very active industry here between 1786 and 1913. Thousands and thousands and thousands of fur seals were harvested and taken to make clothing and hats in Europe primarily, and then in North America and Asia. But luckily that has stopped and populations have recovered. Next slide. We continued to move along the coast, and we hit a number of spots here. It's a fascinating place to go. Most Antarctic expeditions don't really make the effort to go all the way out to the South Georgian island, but it is a very, very spectacular part of the world to visit if anyone should have a chance. South Georgia has no tree cover. It is still a very cold place to come. The terrain is quite mountainous, and it is a very fertile, green, lush area, given how far south it is. And it's a major breeding ground for elephant seals, for fur seals, and for king penguins. Next slide. Let's take a look at some more photos. This is an image of the Stromness whaling station. This is fairly typical. This is obviously fairly run down, but between 1912 and 1931, Stromness was a major whaling station. It was then converted into a ship repair yard, and it remained operational until the early 1960s when it was abandoned. Today, you'll see lots of king penguins and fur seals hanging around for the odd expedition cruise ship to show up. But there are no inhabitants in Stromness, so it is just a place where if you make it that far, you get to walk around and then you leave, and these guys have the run of the land. Next slide. This image, it was a pretty cool day when we went up here. We walked all the way up to those falls in the very rear of the image. They're referred to as Shackleton Falls, and the subantarctic vegetation and landscape is shown quite beautifully in this valley. It's remarkably green, and although winters are harsh, it was alive. You could really feel there's a tremendous amount of productivity and ecology that's active here. The little inset image shows a photo of an Antarctic tern. It's actually very similar to the Arctic tern, but it's a little bit heavier, and it has gray wingtips instead of the blackish kind of tips that you'll see with the Arctic tern. And the breeding of this bird actually takes place between mid-November and early December, which again is the summer in the southern hemisphere. These birds are in pretty good numbers, about 140,000 estimated population. So it's not in terms of wildlife conservation, it's not something of concern. Next slide. This is an image of a bay that we went to, Fortuna Bay. And although it's, again, subantarctic, you can see that this region, South Georgia, is full of glaciers and icebergs. And in fact, this was, I think, our first iceberg. I think this was the first of obviously countless icebergs we ended up seeing. It's a relatively small iceberg, but in that inset image, you can see a little zodiac of our fellow explorers right next to it. And remember, 90% of this iceberg is below the waterline. So while it is a relatively small berg, it is huge if you were to take in its full size into account. it was interesting. We were in the zodiac, obviously, which is just behind here, and we made it a little bit closer. And as we approached this iceberg, our pilot was monitoring the iceberg very carefully, and was quite concerned that it might roll. And sure enough, when he saw the signs that it was about to start moving, he was able to put it into our boat into reverse and clear out of there just in time, because the whole thing actually flipped. And that's fairly common with small icebergs that are still trying to establish their balance. And they create an undertow, like a tsunami effect and an undertow effect, and they're actually very, very dangerous. They can give off as much energy as an atomic bomb, and it can produce even a small tsunami effect for boats that are nearby. So there was a level of danger coming this close to the icebergs, and we had some really expert pilots and captains with us navigating around them. But it is really quite something to see up close, and we weren't expecting to see an iceberg roll over right in front of us. Next slide. Well, here's an image of a beautiful fur seal, and the Antarctic fur seal, despite what the name suggests, is actually resident and distributed in the sub-Antarctic. So you don't really see them in the Antarctic region itself. The males are fairly large. They grow up to 2 meters. They grow up to about 20. They live for about 20 years. Females can tend to live a little bit longer. And there are really, really large abundance of seals in this region. Next slide. The seals were decimated, though, during the industry of furring industry in the 19th century, and nearly hit extinction. By the early 20th century, the species started to recover in certain areas, but they're still threatened. Leopard seals have been noted to take as much as 1/3 of pups that are born in some of these areas, and there's quite a bit of predation. We had a lot of fun with these guys. They often wait for you on the shore as you come on land, and they're pretty aggressive. They'll approach you and want to have some fun, and some explorers can even be bitten if they're not ready for them. But they're very cute, very animated, and they provide quite a welcome when you show up. Next slide. Another unbelievable species. I think the most majestic and regal of the animals that one can see is the king penguin. The king penguin is the second largest of penguins, slightly smaller and very similar in appearance to the emperor penguin. These typically are between 70 and 100 centimeters, so almost a meter high, and very docile. They'll walk up and stand right next to you, and they're remarkably human-like in so many ways. They breed in the sub-Antarctic and have huge populations in South Georgia. But they were nearly wiped out as well by the whalers. The whalers tended to eat the birds and their eggs, and they tend to be pretty rich in blubber as well. Next slide. There's massive colonies on South Georgia. The one that is shown here was tens of thousands in number. Very, very large population of king penguins here. And the image on the lower left shows male and female king penguins actually incubating their young. The king penguin is monogamous, so male and female partners stay together for life, and they share the responsibility for incubating the egg. So the egg actually is balanced between their feet and their belly. And if you look at the base of all those little penguins on the lower left, you'll see there's a little bulge. Well, they actually drape their belly over the egg, which is balanced on the top of their feet and that lump of fat. And it stays warm even in their harsh conditions. And halfway through the process of incubation, the male and the female switch roles. While the other one goes to feed, the other one looks after the egg until it hatches. It was a remarkably sophisticated model. But also very human-like, and they just made us laugh. Very, very, very interesting animal to see up close. Next slide. For the first period of their adolescence, they have chicks have a lot of fur, and the images here show a combination of chicks and adult king penguins. That's called molting, and when they're molting, they have to be very, very careful because, as you can see in the lower right, There are predatory birds like the brown skua that love to eat the chicks and the eggs. So over this very large colony, we saw a lot of predatory bird life that was looking for opportunities, perhaps an egg that rolled away, or a chick that wasn't paying attention, or an injured or an ill penguin that would become dinner. So it's obviously a very, very interesting environment to be able to study and watch. Next slide. After we left South Georgia, you may have to hit it one more time. We started to make our way towards Elephant Island and the Antarctic Peninsula. And this journey over the Scotia Sea was obviously very fascinating for us. It allowed us to process what we had just seen in Georgia Island and start to prepare for where we're about to go. Elephant Island is an incredibly forbidding outcrop that really would be unremarkable for the fact that it was a refuge by Ernest Shackleton and his men, who spent winter there, 4.5 months there, to survive and search for help because their ship had been trapped in the ice over winter. So it was an epic story, one worth reading, that resulted in Shackleton actually going back to South Georgia, signaling for help, and successfully all of the men being rescued after surviving winter on this area. Next slide. This is where they actually sheltered. This outcrop, as we see in the next couple of slides, was where they survived a winter, and that would have been without any communications, without any light, because it's dark throughout almost for most of the year down there in the winter, and rough sea conditions. That's our ship there, and this is just a bit of the perspective. Next slide. You can see a few more images of the region, and that area there with the chinstrap penguins is the area in which they sheltered for 4.5 months. We, even in the summer, could not make land. We had to stay in our ship because to come ashore would have been too dangerous. The ocean was that rough. That little statue there is quite interesting. It's actually a tribute to the Chilean Navy captain who actually came back to rescue them. Next slide. I'll talk more about chinstrap penguins a little bit later as well. So these are more images of Point Wild. It is an area which is really, really unwelcoming. It's a very, very rough area, and one which I think takes incredible photos, but is not necessarily a place you can even make landfall and spend the night on. I don't know how they survive for so long. Next slide. So after Elephant Island, we're now starting to get right into the Antarctic continent and its surrounding islands. We made our way to Spurt Island, which is just the western extremity of the Trinity and Palmer archipelago. And here, as you arrive, you almost feel like you're in a movie set. Next slide. You see these steep canyons and incredible icebergs, and you move through. After Spurt Island, we moved around the coast and touched on a number of locations before making our way back to South America. And these are the locations where we show some more pictures. Next slide. So this is going to be Spurt Island that comes next, and it almost felt like a movie set. It's a volcanic area that is full of birds, and lots of whale life. Steep canyons, geology for a geologist, fascinating environment to visit, and kind of spooky. But we had an incredible time watching the sea life and the bird life in this area. Next slide. Along the way, you see a lot of whales, and you see these gorgeous penguins. These are called chinstrap penguins. They inhabit much of the southern Pacific and Antarctic oceans, and they get their name from a narrow black band that goes under their head. It almost looks like they're wearing a black helmet, and so they're very easy to identify. They're quite aggressive. They're very animated and very social, and they tend to be on top of icebergs, and to be on the outcrops of any of the islands, and they have these incredible porpoising swimming techniques. So they actually swim as a school and they porpoise or jump in and out of the water in incredible synchronization. It's quite something to see. Their diet is really small fish and krill and shrimps and squid, and they can swim for up to 80 kilometers in a day offshore to get their meal. Their main predator is the leopard seal, which we'll see shortly. The leopard seals tend to clear up about 5 to 20% of the chinstrap population annually. They are also at risk to the skua and predatory birds, particularly when they're young. The chinstrap penguin is actually quite threatened to climate change, and because it depends so heavily on krill, Antarctic krill, the sea level temperatures, which often determine the amount of primary production of krill, affect not only the chinstrap penguin, but pretty much all of the food chain. And it's something that climate change scientists watch very closely. For instance, in 2019, an expedition to Elephant Island showed that 50% of the population had declined in just half a century. So they are definitely under some pressure here. Next slide. You'll see fairly soon a pair of different penguins. On the left is a penguin called the gentoo, and on the right is a close-up of another chinstrap, and you can see that chinstrap right there. The gentoo is pretty closely related to the chinstrap, as well as another penguin we'll see shortly called the adelie. And the origin of its name is debated. Some speculate that that white patch on the gentoo's head was thought to resemble a turban. And gentoo was an Anglo-Indian term for Hindus as a distinction from Muslims. So, you know, the name is quite hilarious and their behavior is equally hilarious, but they are beautiful animals to see up close and really, really colorful, and they coexist to be quite comfortably with one another, even up close on a little ice floe like this. Next slide. Well, we didn't just stay in zodiacs. We managed to do a little bit of sea kayaking when we were down there as well. And this is definitely not novice sea kayaking waters, but for those that had some experience, it was a spectacular way to see the sea life, to see whales up close, many of them doing surfacing and plunge feeding. We didn't see any breaching of whales, if people have done whale watching before, but we certainly saw lots of a variety of whales. And we saw a leopard seal, and we saw crab-eater seals as well as these gentoo penguins that are about to dive into the water. That leopard seal that you see there is a major predator of the region. Its only predator is the killer whale. But leopard seals tend to dine on king penguins, adelies, rockhoppers, gentoos, emperor, chinstrap penguins. They also eat seals, other seals, the Weddell seal, the crab-eater, even small elephant seals, and fur seals, of course, as well. So these guys can grow very long, up to 2.5, 3 meters in length, and they are known for their massive reptilian head and jaw. And incredible molars. So these are pretty fierce looking, but very sort of lazy looking things that just sit on top of ice floes until it's dinner time, I guess. But we got fairly close to them. Next slide. Here's some more gentoos. On the left, you can see a mother with 2 chicks in the nest. Unlike the king penguins, they actually do have a rock nest, and they actually do have a different sort of a reproductive role of responsibility. And the chicks are actually quite young and fed for quite a bit longer than the other types. And the gentoo's diet is high in salt, and because they eat so much salt, they can have complications with sodium concentrations. So they actually have a way of secreting that salt through salt glands that are just above their eyes. At sea, these guys are very much at risk to leopard seals, sea lions, killer whales. On land, they don't really have any predators once they're fully grown. So the chicks are a little bit vulnerable, but certainly once they become adults, they're pretty much safe. Here's another bird. This is called an Antarctic cormorant, often referred to as the Blue Eye Shag. These grow 70 to 80 centimeters in length, and they have an incredible diving capability. They can dive to 25 meters, and at up to 60 meters. Actually, on average, they dive to 25 meters to fish. And they'll often fish in groups that can number in the hundreds. And when they organize these groups, they're known as rafts. They'll come fairly close to shore and they'll herd fish towards other raft members to eat. So they have the intelligence that we tend to associate with killer whales and other animals that do this kind of wolf pack kind of feeding in the oceans. Next slide. This is a collage of more images and impressions from Antarctica. You start seeing the incredible light and the blue tone of the icebergs. There's an image of another beautiful humpback. By the way, we saw humpbacks, fin whales, sei whales, minke. We didn't see any orca on this trip, but we saw quite a wide range of whales down there. In the upper right, this is an example of a typical research station in Antarctica. And you can see that this one, which is one of 13 research bases operated by Argentina, is what you see is what you get. This is pretty much all there is there. And the staff that are associated with this base really don't have anywhere else to walk around or go for a run or go and do a shopping or anything like that. This is their home for their season or for the year, and they tend to go away from these bases to do their science, and then literally come back here for their camp and for their documentation and writing. This base actually opened up in 1951, originally the Brown Research Base, and it has served pretty much since 1984 as just a summer-only station. And this area, which is called Paradise Harbor, is relatively mild weather-wise. It can be sheltered by stronger winds because of its nice surrounding mountains, and it's quite a rich and biodiverse area that we spent quite a bit of time in. This is another penguin. So we've seen king penguins, we've seen chinstrap penguins, we've seen gentoo penguins, and now we're looking at another species called the Adelies. And they're common throughout Antarctica or around its periphery. So they're fairly widely spread penguins species. And they're named after the wife of the French Antarctic explorer, Adèle Dumont d'Urville. The explorer's name was Jules Dumont d'Urville. And he discovered this penguin in 1840. They're fairly good swimmers, and they're really incredible to watch near the water because they have the ability to jump up to 3 meters out of the water and land on rocks or ice. So one might be standing just looking at a body of water and seeing these in the water, and they will literally leap out 10 feet and land on a rock crop or an ice. It's something that you really are amazed to see up close. The other thing special about this particular species is their rim around their eye. They have this turquoise blue luminescent rim around their eye, and they all have it. It's quite phenomenal in the light that you see them in. Next slide. There are some more Adelies on the top left, and some more images of Antarctica. You can see here in Petermann Islands, beautiful icebergs, lovely light, kind of the ship in its majestic beauty. Really a beautiful part of the world to have a chance to visit. Next slide. There's one more seal that I'd like to show you here. It's called a crab-eater seal. This is in Petermann Island as well. Despite its name, the crab-eater does not feed on crabs. In fact, there are very few crab species in this part of the world. So it is largely a krill eater, and it has teeth that are designed to actually filter the krill very effectively, and it's quite an expert harvester of Antarctic krill. Therefore, it is also dependent on the krill production and the effects of sea temperature and climate change, as are all the other species. And young seals tend to be very, very much at risk to leopard seals. In fact, mortality is pretty high in their first year. 80% of them can make it through their first year. but they'll have scars and they'll have remnants of attack from other species of leopard seals and even killer whales. But once they make it through their first year, they tend to be fairly capable of living a long life. Next slide. I'm just reaching the end of the expedition here. So after we had some fun in Antarctica, we sailed across the Drake Passage, which is also a very legendary name. It was about a 709 nautical mile journey. And in fact, that journey is the shortest crossing from Antarctica to any other landmass. It's 4 times farther if you were to go from South Africa to the closest part of Antarctica. So it is the quickest and the shortest journey, but because it is through a narrow channel, it happens to be one of the roughest seaways in the world. So that passage, the Drake Passage, can sometimes be a very treacherous crossing for ships. We had a relatively mild journey, but it can be quite brutal. The reason why it's so rough is that around that channel that you see there, you have the circumpolar current, which carries massive amounts of water in a circle around Antarctica. So as it moves at that fast speed, it actually flows the equivalent of 600 times the flow rate of the Amazon River. So it's a massive volume of water that's passing through that narrow channel before it spreads around the South Atlantic and then comes around under Africa and turns into the South Pacific and South Indian Sea water. Next slide. All right, coming to the end here, and I hope you enjoyed those pictures. I wanted to really quickly touch upon governance. I think a lot of people are unsure about, kind of where does Antarctica fit in terms of how the world manages it, and is there some sort of a convention to managing it? Well, the good news is that there is. In 2002, in fact, that blue flag did not exist, and Antarctica had no flag. But in 2002, the signatories to the Antarctic Treaty System officially adopted that flag and emblem, and that is officially the symbol as of the last 18 years for Antarctica. That map on the left shows the signatories and non-signatories to the treaty. The orange countries are the ones that still have some historical claim to Antarctica, but in fact, one of the conditions of the treaty is that there would be no new claims, and there's no mutual recognition of anyone else's claims under this treaty. So there are sort of levels of commitment that have been made by the world, but you can see there that Canada is a consultant to that treaty, but is not that active. We have no claim to Antarctica, and we are simply at the table with a little bit of scientific research there. So clearly, Canada is very much committed to the Arctic as opposed to the Antarctic, but we do have some work that goes on in Antarctica. The Antarctic System actually came about under signature in 1959 and came into force in 1961. And it was originally signed by the 12 countries that had significant interests in Antarctica. So those were Argentina, Australia, Belgium, Chile, France, Japan, New Zealand, Norway, South Africa, the Soviet Union, and the United Kingdom, and the United States. Collectively, those countries had some 55 research stations. And in the International Geophysical Year, they came together and said, well, it makes sense for us to reduce tension here, international tensions, in terms of the governance and the use of Antarctica. And I think particularly in the context of the Cold War, President Eisenhower convened an Antarctic conference that brought these countries together to commit to a peaceful use, only for scientific use, and not for nuclear testing or military use, and not for mineral exploitation. So that is the genesis of the Antarctic Treaty, and many members now have signed on, and it is collectively, I think, well recognized, and a tribute to the members of the world to actually come together. I think it's an indication that we can work together, we can manage common property and common resources relatively well, and it's been an effective agreement for many years. Next slide. These are the key points of the treaty. There is no allowed use for military purposes in Antarctica. There was quite a bit of attempts to use it for military testing and positioning during the Second World War. There is freedom of scientific investigation. People are allowed to study a wide range of areas of legitimate science. There must be exchange of that scientific research, and no proprietary claims to that. Any new claims to territory are no longer entertained by the international signatories to the treaty. It's a nuclear-free zone. Its remit is just to the land, not the seas that surround it. And any research station and any country which operates research stations is allowed to inspect the research stations of other treaty members. So it is self-enforcing and reciprocal. And when you're in Antarctica, the laws of your citizenship apply. So as Canadians, when you're there, we must abide by Canadian law. There is no Antarctic law per se. And you get the sense that it is really quite something where it is a mutually enforcing trust, voluntary commitment. You don't have to be a signatory to Antarctica to be able to go there, but the world actually realized that it was in its greater interest to do that. And it's quite a strong testament to the fact that we can work together. Now, Canadians have been involved in Antarctic research for more than 100 years, and we tend to work with partners. We have 15 different Canadian universities and 4 federal government organizations that engage in Antarctic research. Most of it has been associated with technologies and performance testing of technologies. And we ratified as a non-consultative member our commitment to the Antarctic Treaty in 1988. We tend to do quite a bit of scientific outreach and education there. Canadians made the 6th largest number of tourists to Antarctica. In 2015, we make up about 5% of all the Antarctic tourism, indeed. And our products, including skidoos, performance apparel, other equipment, tends to perform very well in Antarctica. So you'll see that quite a bit down there. All right, I'm nearly done here, and I wanted to finish a little bit more on climate change before we open it up for discussions. So there is a very significant, go to the next slide, there's a significant climate change agenda that the Antarctic Treaty members have, and it's managed through the Scientific Committee of Antarctic Research. And really, it's beyond the scope of today's presentation to go into it, but I think that it is really a wonderful body of research that's available at that website, scar.org, that I would encourage you to visit if you are interested in these issues, and maybe it's the subject of a future webinar if there's enough interest. So, I mean, what is our role for climate change? Well, I didn't want to sort of put myself on the line, so I thought I'd refer to our friend, Dr. David Suzuki. So let's go to the next slide and see what he says we need to do about climate change. He has top 10 ways. I've reduced them to 7, which I thought was appropriate. So let's see what he says. Number 1, if you just want to advance these bullets for me, 1 is to get united around bold climate action. So I think together we really do need to think about sending a strong message about climate action to our federal and our provincial and local leaders. It should be non-negotiable. It doesn't really happen significantly on an individual level. We do need to have government make commitments, and I think our democratic powers really are going to make a very big difference in future elections about whether we do anything about climate change. Could you advance the bullet points, moderator? The next one. The next comment that he has is to use energy wisely. So Canada is the top consumer of energy per capita per world. We are the problem. And continuing to consume oil and natural gas is really the problem. So I think that it also comes down to a household level, an individual level, in terms of our energy use. He also says, next point, that we need to really get behind renewables. Think about solar panels, think about electric vehicles, and really commit to that. Changing our diet. I think a lot of people now have realized that moving towards a meat-free or a highly plant-based diet has a very significant impact on climate change, and buying local, buying organic, not wasting food, even growing our own food can actually have a very significant impact if we want to feel like we're making a difference. The next point is that he suggests that we start a climate conversation. Just raise this topic with your friends and family and keep it in front of mind. Part of my motivation today in speaking to all of you was to make sure that I don't lose this opportunity to advocate the individual and the ethical responsibility that each of us have to dealing with this problem. And we could see climate change manifesting in front of our eyes in Antarctica everywhere we went. We had some amazing stories of how quickly things are changing there. The next point is to green our commute. Really, I think a lot of people understand what it means to get out of our cars and to walk and ride a bike and take public transit, use car sharing, fly less, offset our emissions. There are really a large number of things that we can do to make us healthier, make us happier, and save money. And really, the latest Porsche is probably not going to be consistent with the vision that I think most of us espouse in terms of climate change. And the final thing that I will paraphrase him on is that we should consume less. We should waste a lot less. And next part is to enjoy life a lot more. And I think that the current experience that we have living through a pandemic has I think, caused all of us some pause and given us an opportunity to reflect about our consumer intensive lifestyle and perhaps what that means in terms of our overall happiness. Well, I'll finish off there. Next slide. I think we'd all be happier if this guy can relax comfortably on the ice. He can literally chill for a long time to come. Thank you. I'd love to open it up to the rest of this group if they would like to share their experience, and I'd be happy to answer any questions that you might have. Thank you.
Thank you so much, Firoz. That was absolutely fascinating, and I love your pictures. They're stunning. I've had lots of people comment about the absolutely gorgeous pictures. Personally, I love the penguins myself and the icebergs as well. So we have some time for questions. I'm going to start with there were a number of questions around climate change, and I wonder if you could talk about some of the most dramatic effects of climate change that you actually saw, and what are some of the predicted effects on both the ice shelves that you talked about, as well as the bird and the sea life. Could you start by talking about that, please?
Sure. Okay. Actually, I'm going to open up some notes. I do want to actually answer these questions with a little bit of science. Yeah, it was manifesting very obviously and apparently in some ways, and in a nuanced ways in other ways. I'll refer to a story. When we were at one of the bays in Antarctica, we climbed a little bluff and we're watching some of these beautiful Gentoo penguins playing, and we asked somebody who had actually spent 8 years of his life doing seal research, an Argentinian scientist, Federico, and somebody who I think most of his colleagues even revered. He really was a very credible Antarctic scientist. Had spent many years, many seasons, and had done some really groundbreaking and best practice development with dealing with Antarctica. And what he said was that you could actually measure year-over-year changes, and we were seeing things further south. We're seeing wildlife and sea life further south than we should be seeing. We were able to get further south than we should have been able to come even a few years ago. So in terms of accessibility and ice coverage, it was far less. And I believe it was in late January, early February, that the temperature in the area that we were standing, Antarctica, was the same as it was in San Diego. And you literally could have been in your short sleeve shirts in Antarctica as you would have been in San Diego. So it was 18 degrees Celsius. So it was remarkable how vivid and how apparent it was. But what he also said was that it's not that simple. It's not that you can, like Canadian weather, you can't sort of treat it as a homogeneous fact. There are parts of Antarctica which aren't as warm. They aren't warming as quickly. In fact, they are still incredibly cold, minus 60, 70 degree temperatures. The South Pole's average temperature in the summer is about minus 25. So it is still an incredibly cold place. But in the Western Antarctic, and particularly around the perimeter of the continent, you're starting to see the effect of warm water as well as warm air temperatures. And that warm water was in the news recently because it seems to be undermining the ice shelves that have historically been nicely locked onto the bedrock. And because that warm water is flowing underneath the ice shelves, it's actually causing a double threat to the stability of those ice shelves. And when that warm water creeps in underneath the bedrock, it loosens the shelf enough so that it can break off. And as I mentioned, whether it's the Thwaites, whether it's the Ross, whether it's the Rhone, whether it's the Denman ice shelf, which is on the eastern part of the Antarctica, we tend to think of it as not being as at risk, they are all starting to show that level of vulnerability. And the scientists are spending quite a bit of time drilling into those shelves, looking underneath those shelves, and confirming that water temperatures in some cases have risen by 2.5 degrees in the Antarctic. So that's the kind of example that you would hear from the people that are really experts in climate change.
Thank you. I think we should send Trump there so that he can see for himself firsthand that there are these changes occurring. Just a couple of follow-up questions about climate change. How do you see tourism affecting climate change, particularly in Antarctica?
Sure. I mean, there's no question. It has an impact, and it was definitely the paradox of going there. And it weighed heavy in the hearts of most of us, because I think most of the people on this cruise were very, very environmentally concerned, very, very eco-sensitive, and yet we had flown from the northern hemisphere all the way to the southern hemisphere, and we were sitting on this incredible ship and steaming around and having fun. And that contradiction was not lost on us, and in fact, many of us spent many evenings and meals debating it. I think the most pragmatic response to that was that, and this came from another very seasoned Antarctic scientist that was on board with us, was, we would, if we don't go there, and if we do not invest in a high value industry for professionals, and it leaves behind obviously a lot of resources for the conservation of the region, then in that vacuum of a lack of tourism will come some other force, which will typically be resource exploitation. And it could be whaling, it could be other sort of sea life and fisheries. It could even be mineral exploration. So between the two, I found the most pragmatic response was that high value, eco-sensitive and incredibly eco-sensitive tourism is actually in the overall interest of Antarctica. And we had to go through formal training in order to get off the ship. We had to go through very, very intensive screening. And our equipment, our footwear, everything had to be sterilized every time we boarded and disembarked and embarked on the ship. We weren't able to take our own things on land. You're not able to take any souvenirs off Antarctica. It is really, really protected. And it's testament to the value of high value tourism. So if we really are concerned about climate change, we shouldn't leave our homes, right? We should not even fly between provinces. But we took the trip out there, and I think that we had an impact, which we offset. And we've come back with, I think, a motivation and an ambition to make a difference that justifies the trip. But I think bad tourism would be really harmful. Good tourism, I think, can have a very positive impact on Antarctica.
Great. And I think it really makes us think about how, when we take our trips and when we plan our trips, what's the best way so that we're not leaving a huge footprint. A couple of just different kind of questions now. A number of people are asking about the remnants of past civilizations in the Antarctica. How long has it been inhabitable? And if you could just review, just very briefly again, how Antarctica was formed in relation to that, and whether who are the indigenous people that are still living in the area, and if you came into contact with any of the communities there.
Okay, actually, Yeah, there are no indigenous populations in Antarctica, so there is no history of human inhabitation in Antarctica. It has never been settled. In fact, it was really something that was never proven to exist until 1821. There was a German explorer called Bellinghausen who was the first to actually make sight of the Antarctic continent. He actually did not make landfall. He was not able to penetrate the ice, but he was the first to actually confirm its existence. So there has never been any human inhabitation of Antarctica. And James Cook never even set foot on Antarctica. He just actually tried to get close to it. He never saw it. He surmised there must be a southern continent, but it would be so inhospitable and so forbidding and so worthless that the British Empire should direct its explorations to more friendly areas like Tahiti and the South Pacific, I guess. So, you know, it really is not an area that humankind has had much experience with until very recently. So, as I mentioned, Bellinghausen was the first to make sight of it, but apparently the first to make landfall was a whaler, an American whaler, in the late 1800s. So, about 120 years ago. And that the records of that visit are even disputed. So we actually have only had a very recent acquaintance with Antarctica, and the South Pole was reached by a Norwegian explorer, the Roald Amundsen, in 1911. And an attempt was made just a few weeks later by a British contingent led by Robert Falcon Scott in 1912. So, you know, we've had about a century of regular involvement in Antarctica, but no long-term inhabitation. There are no indigenous communities. There are no permanent inhabitants even today. There are just scientists that might spend 1 or 2 or 3 years based out of a station.
Great. There's a question about well, there's 2 more questions, and I just want to encourage people. We do have a few more minutes, so if anyone has other questions, please send them along on the questions tab that is on the right-hand side of your screen. So one question is about the lines that you showed on one of your slides for Point Wild and Elephant Island. Can you tell us what those lines mean on the rocks? Were they formed by the tectonic shifts or erosion? If you could just explain that to start with.
Yeah, I won't even pretend to be a geologist, and the geology of Point Wild is really something which I'd be happy to share some more information about. I do have some excellent resources, but you can see the stratification, you can see the faults and folds. They're pretty obvious, and in terms of the metamorphic processes, I think it would probably be a pretty tough discussion for me to attempt right now, but I'd be happy if the person who sent that question, or if you could note the email address, I'd be happy to share some really good websites and resources on the geology of that region.
Okay, great.
It's absolutely spectacular, and you will discover fossils that predate Antarctica's current location there. So you'll see subtropical fossils, sea life, dinosaur remnants, birds, plants. So these rocks really do tell an ancient story about where that landmass came from and where it now finds itself. So it's a relatively recent thing. Geologically, where we were at Point Wild is a relatively new geological process. Whereas as you move around Antarctica, you see geological processes that date back hundreds of millions of years. So it is a fascinating and very varied continent geologically, and there's some really great resources out there that I'd be happy to share.
Great, thank you. Just one last question, and then we're going to wrap up about the penguins. You showed a picture of the penguins where both the male and female take turns looking after the eggs, incubating the eggs in that little flap. Do you know if both the parents actually look after the babies after they're born?
So yeah, so the chicks actually, when they're born, they wean through both the parents, and they grow very quickly. So the chicks either survive and make it through adolescence, or they are the victims of predator birds. And so those that actually make it, they grow very quickly. They have very rich milk. They have very rich weaning and regurgitation feeding practices, so that they get to a critical mass, a critical size. And they go through a process called molting. So I'm thinking of the king penguin, for example. It molts over a period of a couple of months, and during that period of time, it is quite vulnerable. It doesn't have the thermal barrier, the thermal protection that it needs, because its adult feathers haven't grown in, and its chick feathers are falling off. That brown feather gets replaced with that beautiful black and white coat. And during that period of time, they actually are prone to hypothermia. So they do all sorts of things to stay warm. But once that chick is past the nest, they have a limited period of time of weaning, and then they are pretty much on their own. They mature very quickly. Now, I'm talking generally about penguins. Obviously, each species has their own sort of reproductive and adolescent periods and times and processes. But generally, that's the key point, that they tend to have to either make it through adolescence very quickly, or they won't survive.
Great. Thank you, Firoz. I just want to say this was an absolutely fantastic presentation, especially while we're all sitting at home and can't travel anywhere. It was great to see your experiences, your travel. You're like even Batuta, who went out and explored the world. So thank you so much for sharing that. We really.
It was my pleasure.
I want to talk just quickly about some of our amazing speakers that are coming up in April. Our next speaker is going to be Dr. Farzana Meru, who's an astrophysicist in the UK. She's going to be talking about her work on extrasolar planets, which should be really fascinating. So we're going from Antarctica to outer space. We'll then have Dr. Hussein Rashid, who's a professor at Columbia University in New York, and he's going to be talking about Muslims and popular culture. I think the title of his talk is going to be Hazrat Ali and Comics, so it should be very interesting. And then the last speaker in April is Dr. Azim Sharif, who is talking about the dilemmas, the ethics of self-driving cars. So of particular interest to those of us who have self-driving cars, I think will be really interested in that discussion. So I encourage all of you to attend these absolutely amazing speakers who are going to come up in the next couple of weeks on Saturdays. We have a survey, so we would love it if you would fill out the survey. Let us know what you thought about this webinar. If you have any other suggestions for any other topics or webinars, if you have any questions about today's presentations and would like to forward your questions to Firoz, please send them to me. My email is just at the bottom of that slide. And I'd appreciate hearing from anybody about any other suggestions that you think that we could to try and make this series even better than it's going to be. So thank you all for joining us. Thank you, Firoz, again, and Yali Madat, and hope to see all of you again next Saturday.